In question 8, we've been given a parabola and a straight line. So what I'm going to do is fill in all the points. My parabola is going to be blue and my straight line will be green. And now we need to show that the equation of J can be written as what they gave us over here, this minus 2x squared plus 4x plus 6. So we need to get the equation of the parabola essentially. Now there are two equations I can utilize to do that. I can use my turning point equation or my x-intercept equation. I think I'm going to use the turning point equation because I have the turning point. I've got one x-intercept but not the other. So I'm not going to go for this one. And we're going to use the turning point form. And now we're going to fill in our turning point. So the x value of the turning point is 1. So I'm going to change this p to a 1. And then the q value, the y value of the turning point is 8. So I'm going to change this q to an 8. And then we need to get the a value. And to get the a value, I'm going to sub in a point that's on my graph. So I can choose any point except the turning point because we just put that in. So I'm going to choose this, the y-intercept, and I'm going to sub it into my function. So when I sub it in, I just replace y with the 6. And I replace x with the 0, and then I work out a. First, we are going to move this positive 8 over to the other side of the equation. It becomes negative 8, and that will give us negative 2 on the left-hand side. And then on the right-hand side, that a can stay there. 0 minus 1 will just give me minus 1, and if I square that, it just gives me 1, and 1 times a is just a, so we get a to be negative 2. Now I'm going to grab that a value and I'm going to sub it back into this original line to get a new line that looks like this, where I have the negative 2 replacing a in this line. And now the square is talking to me, but it's telling me to write the bracket twice, my bro. So we're going to write the bracket twice so that we can FOIL. We FOIL out these brackets to get x squared minus 2x plus 1. And now we're going to get this negative 2 in the bracket by distributing it to all three terms. And after we do that, we get minus 2x squared plus 4x minus 2. And we have that plus 8 chinchillin at the end. And minus 2 plus 8 gives us 6. So we've officially arrived at the final answer. Check there. J of x minus 2x squared plus 4x plus 6 minus 2x squared plus 4x plus 6. And the slagmense only award 3 marks over here. 1 for your substitution of both the turning point and this coordinate. 2nd for your value of a. And 3rd for your correct simplification. In the next question, we need to calculate the average gradients of j between the x value of 1 and the x value of 3. To calculate average gradients, we just use our gradient formula. So we're going to need 2 points, and they're specifying the points here. So they want the points at x equals 1. Do we have that point? We do indeed. It's t. So we have the first point that we're going to put into the gradient formula. But we don't quite have the second point. I mean, we have like half of it. We've got the x value. So to get the y value, we need to sub it into the respective graph. So we're going to sub it in our blue graph because we're getting the average gradients of j in the blue graph. So we're going to start off that process by saying j of 3. Instead of saying j of x, I'm replacing all the x's with a 3. And that's exactly what I do in this next step here. I just replace all my x's with 3's. You can see 3's have replaced these x's. Okay, let's go ahead and chuck that in the calculator. Alrighty, Dr. Calculator, how's it, brother? Underbut. Okay, so j of 3 is 0. So that tells me that the y value is 0. So this point is actually the point Q. Okay, so now we know the other points that we will be putting into our gradient formula. So let's chuck these guys in. I think I'll just put t in the blue guy's place. Just remember the y values go on top. I'll put q in the pink guy's place. And then ain't nobody got time for that, bro. That's going straight in the calculator, bro. So if we just slap it in there, it gives us negative 4. So the gradient or the average gradient of our graph between x equals 1 and x equals 3 is -4. It's a straight line that's drawn through T and Q. Okay, let's have a look where our 3 marks are coming from. First mark comes from the correct coordinates or points, second mark for your substitution, third mark for the final answer. In question 8.3, we need to get the coordinates of P, which is a point of intersection of J and K. And to get points of intersection, you simply equate the two graphs. So we make the parabola's equation equal to the straight line's equation. And now to start working on this fraction over here is really bugging me. So I want to get rid of it quickly. And to do that, I'm going to have to times by 3. But if I times that term by 3, I'm going to have to times every single term by 3. Okay, so if we go ahead and do that quickly, we're going to get minus 6x squared. 4 times 3 will give you 12. 6 times 3 will give you this 18. The third times 3 gives you 1, so you get 1x. And 1 times 3 will give us 3 over there. And now to start solving, you can see that we have a quadratic equation. So we need our standard form, so we're going to get everything to one side and make it equal 0. So I'll start with the x squared term, this minus 6x, move it over to that side, and it becomes positive 6x. And then let's do the x's. So we're going to move this 12x over to that side. It becomes minus 12x. 1x minus 12x will give me minus 11x in the middle. And then if I move this 18 over, it becomes minus 18. Minus 3 minus 18 gives me this minus 21 at the end here. Now we've got the laborious task of factorizing this bloody trinomial. And to start off that process, we are going to set up the tennis court method. So I'm going to write the factors of 6 underneath each other in the front over here. So we can try 1 and 6 or 2 and 3. I'm going to start off with 1 and 6. And then we also use the factors of 21 over here. I'm going to try 3 and 7 to start off with. And then I multiply going across the court. So 6 times 3 will give me 18. And 1 times 7 will give me 7. Now I need to add or subtract these two numbers to get this minus 11 in the middle. And I think I can get that done by saying minus 18 plus 7. And then we transfer those signs back in. And these form our two brackets. Our first bracket, we just chuck a little x here, chuck a little x here. And then my first bracket will be x minus 3 over here when I factorize the trinomial. Then my second bracket will be 6x plus 7, which I will put over here. And from these two brackets, we're going to get our two answers. This one will return us an answer of positive 3, because if I made that factor equal to 0, take the minus 3 over. This factor over here will return us an answer of minus 7 over 6. Take the 7 over, becomes minus 7, divide through by that 6, and you get minus 7 over 6. Now we've got to decide which one belongs to P and which one belongs to Q. Okay, that's quite a clear-cut decision. We can already see Q is 3. So we're going to put a stroke through the equal sign here because we're not using that one. We're interested in the coordinates of P. So this one is relevant to us. Now we've got like half of P. We have its x value. And if I'm missing the y value, if I'm missing its partner, all I need to do is sub this in to get it. So I can sub it into the blue graph or the green graph. This point lies on both of them. The green graph looks a little bit easier to me, so I'm going to substitute it into that graph. So I just replace x with my x value here. We're going to chuck that in the calculator, and we get minus 25 over 18. And now we have the coordinates of P to be minus 7 over 6 and minus 25 over 18. And your 5 marks will be earned from equating the two graphs, standard form, factors, answers with the exclusion, as well as the correct y value. In question 8.4, we need to get the maximum length of VW. So what we do is we have a look at VW, and we recognize which graph is on top and which graph is at the bottom. And then we get an expression for VW by saying the top graph minus the bottom graph. And then when you minus the bottom graph, do not forget brackets. That is crucially important. And now just bear in mind this process only works for perfectly vertical lines. At the beginning of the question, they told us that VW is parallel to the y-axis, which is a sneaky way of telling you it's a perfectly vertical line. And the first thing we're going to do to start simplifying is distribute this negative into that bracket to get rid of it. Okay, then we're going to do our like terms. So we're going to do 4x minus a third x. The minus 2x squared will just stay in the front, by the way. And then, I'm going to use my calculator to help me out with that one. Hey? I don't want to work with fractions, don't want to waste time doing that. So it's always better just to pop it in the calculator. It gives us 11 over 3. So in the middle we get plus 11 over 3x, and 6 plus 1 will give me the 7 over here. Now next up we need to get the turning point of this expression for VW. So I'm going to use my magic formula. The turning point formula minus b over 2a. Right, so let's chuck in all our goodies. B is the number in front of x, so it's this 11 over 3, so it's the minus version of that. And then a is the number in front of x squared, so it's this minus 2 over here. That goes straight in your calculator and returns you a value of 11 over 12. And then I grab this 11 over 12, I substitute it back into this line for VW, and we get our substitution step as follows. Type that in the calculator, and we get 625 over 72 units, which is about 8,68 units. And there's your max length of VW. And your 4 marks are earned from the correct method being applied, your simplification, the correct method to get the turning point, as well as the correct answer. In question 8.5, I need to use the graphs to determine where j increases, and we just state x values for our answers. So j belongs to the parabola, so we're going to ignore the straight line for this question. And intervals of increase and decrease all revolve around the x value of your turning point. And the trick is to read your graph from left to right. So I start all the way on the left, and if I go on top of this graph, you pretend like you're driving on it. You can see you're going uphill. So that over there is an interval of increase. So every x value that's smaller than 1, your parabola is increasing. Then as we cross the turning point, so as our x values get bigger than 1, our graph will start to decrease. So they want the interval of increase, so we're just going to state whenever x is smaller than 1, our parabola increases. And another notation is possible. You can say like from minus infinity all the way up to 1, and then we use circular brackets. We don't include the turning points because it neither increases nor decreases at that point. Okay, the next question is a very tough one. We're going to start off by dividing both sides by a negative, because this negative here is making our lives very complicated. So let's divide both sides by a negative. So on the left hand side, these negatives will cancel, and it will just leave us with j of x over k of x. And then on this side, we can see that the inequality has swapped directions. 0 divided by negative 1 is just 0, by the way. And the inequality swaps direction because I divided by a negative. Don't forget that small rule. Ooh, and now to analyze this inequality. So they're asking you, where is the y value of the blue graph divided by the y value of the green graph give you a positive number? Anything that's bigger than 0 is positive. And we can get that by saying a negative over a negative, or we can say a positive divided by a positive. Now your best strategy to do this is to draw vertical lines through all the x-intercepts you can find. It doesn't matter if it belongs to the green or the blue graph, but I'm going to draw vertical lines through my x-intercepts, r and q. And then on either side of those lines, I draw a little vertical line. So I draw a little vertical line here, and then I'm going to draw a little vertical line in the middle of the gray lines. So I'm going to draw one there. And then I'm going to draw a little vertical line over here. And now I can analyze basically, you see there I have a negative y value, and there I have a negative y value. So I've got a negative divided by a negative. So it's actually working in this region here. So it's working whenever x is smaller than negative 1. Okay, over here in the middle, I have a positive y value. You can see that it's a positive y value because it's above the x-axis being divided by a negative y value. So that's not working. It's not giving me one of the two cases I want. And then if I cross this x-intercept, I've got a positive y value over there because it's above the x-axis. And I've got a negative y value there for the blue graph. So I'm going to get a positive divided by a negative or the other way around. So that won't work. So the only place it's working is over there. And we simply just write that like this. X is smaller than -1. And now we just quickly have to address this equals to symbol. So we've got to be careful at this point over here. So the blue graph is on top in this inequality. Okay, so we actually safe to include -1. And that's because I'll get 0 on top of the fraction. So I'll get 0 on top here and some negative number. I think we actually even got it in the previous question. So I'll get 0 divided by a negative number, which will give me 0, and it will work. If the bottom was 0, I'd have to exclude it, if you know what I mean. Okay, let's have a look where our 3 marks come from. All 3 marks are simply just awarded to your answers in this case. Wrapping up question 8. For which values of k will j of x minus k have 2 distinct roots? So the first thing we do is we're going to take this negative k over to the other side of the equation so that we get j of x is equal to k. Then what we have to do is kind of picture k to be a horizontal line. And I can place this horizontal line in 3 specific spots over here. So I can firstly place it anywhere above 8, and then it will not touch my parabola. And then I can place it exactly on 8, and then it touches my parabola once over here, and we regard that as equal roots. And the other place I can put it is below 8. And when I put this line below 8, I'm going to get 2 separate roots. Now, what's important to realize with these questions is the intersection points between your parabola j and this horizontal line k are the roots they're actually talking about. So they want you to place this line so that you get 2 unequal, aka distinct roots. So they want you to place the line anywhere below 8 to get those 2 points of intersection, aka roots. So our answer is simply just whenever k is smaller than 8. And you simply just get 2 marks for your answer in this question.